Today, we're going to go ahead and learn how to simplify square roots and how to deal with some odd inequalities. So let's go ahead and take a look. So our first part that we're going to be working on is simplifying square roots. And the first thing that we need to look at when we're simplifying square roots is what perfect squares are. So we're going to start with looking at perfect squares. So perfect squares are ones that come out without a decimal when we take the square root of them. So we know that 1 squared is 1, so that means that 1 is a perfect square. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, so 9 is a perfect square. 4 squared is 16, so 16 is a perfect square. 5 squared is 25, so 25 is a perfect square. And continuing on, so we have 36 is a perfect square. We have 49 is a perfect square. We have 64 is a perfect square. 81 is a perfect square. 100, and this, of course, continues forever and ever. So when we have something like the square root of 12, we know that the square root of 12 is not a perfect square. It's not one of these numbers to the right. However, there is a perfect square inside of the square root of 12. And so we're going to go ahead and take a look at the factors of 12, and we're looking for one of those factors to be a perfect square. So I know 1 times 12. 1's a perfect square, but that doesn't change the problem. I know that 2 times 6, 2 and 6 are neither of those are perfect squares. We have 3 times 4, and 4 is a perfect square. So we're going to rewrite that as the square root of 3 times 4 underneath that square root. And then we take a look at that perfect square, which of course is 4. And so we're going to go ahead and solve for that. The square root of 4 is 2. So we're going to take that and we're going to put it outside our square root symbol, write our square root symbol, and we're going to leave what is not the perfect square underneath that square root sign. So we have 2 times the square root of 3, and that is my simplified square root. My second one here is the square root of 45. Once again, I'm looking for those factors. I have 1 times 45. Neither of those are perfect squares that would change the problem. 2 doesn't go in evenly. 3 times 15. Neither of those are perfect squares. 4 times doesn't go in evenly. So 5 times 9. And 9 is a perfect square. So we're going to rewrite that as 5 times 9. So we go ahead and we take a look. And we are going to solve for that perfect square. The square root of 9 is 3. That goes on the outside, and the square root of 5 stays on the inside. Okay? So this is kind of like reducing a fraction. As we reduce a fraction, like for example 3/6, we reduce that to 1/2. So the same thing, we're putting it in the simplest form. Sometimes, however, we don't reduce it all the way the first time. So I know 72 is going to be 8 times 9. And I see that 9 is my perfect square. I take that out, square root of 9 is 3. So that's 3 times the square root of 8. And I think I'm done. However, my 8 still has a perfect square in it. It's 2 times 4. So I go ahead and I go 2 times 4, and I need to simplify all the way down. And when I take that square root of 4, which is 2, I multiply it by what's already on the outside. So 2 times 3 is 6. So my answer is going to be 6 times the square root of 2. So sometimes you need to continue until you get all of the perfect squares out. However, you might have seen this as 2 times 36. And so there's multiple ways that you can solve this. The square root of 36 is 6 times the square root of 2. Notice we got to the same answer, but because we'd taken out the biggest perfect square, then I only had to do it once. So we always want to take out the biggest perfect square that we can as possible. Now, in your Khan Academy, you're going to see something like this occasionally, and this is after you solve the quadratic formula. You might get an answer, -6 plus or minus the square root of 72, all divided by 3. And I see that that square root of 72 is not simplified. We've done it up here. So we're going to replace it as negative 6 plus or minus 6 times the square root of 2, all divided by 3. Now, when I see this, I look at the numbers that are all outside of my square roots, and I see that 3 goes evenly into all of those. So that means that I can reduce it even more. Negative 6 divided by 3 is negative 2. Plus or minus 6 divided by 3 is 2 times the square root of 2. So you're going to run into this Khan Academy where you think you have a right answer, and then this is the answer that you see. So a couple ways that you can deal with that. One of the ways is that you can go ahead and plug that into Desmos and look for that estimated answer as well, because Khan's looking for the most simplified answer. Let's go ahead and take a look at some odd inequalities. And you guys have started this last class. And we're going to be practicing it today in our Desmos activity. So we're going to look at 3 situations for our odd inequalities. So our first problem here, and once again, we're solving for these inequalities, is x minus 6 is less than 15 plus 8x. And so we're going to go ahead and solve for x. So I'm going to subtract x from both sides. That leaves me with negative 6 is less than 15 plus 7x. I'm going to subtract 15 from both sides, and that gives me negative 21 is less than 7x. And I'm going to finish up by dividing both sides by 7. Remember, if you divide by a negative, then you would have to flip that sign. So that cancels out. Negative 21 divided by 7 is negative 3 is less than x. However, in our Desmos activity today, all of your answers need to be typed in with the x first. So the way that I look at this is I go ahead and put my x here and my negative 3 here. And then I'm going to go ahead and see that my 2 dots for my inequality are closest to my x. So I'm going to make those the closest, and 1 dot's closest to my number. And so that's just an easy way to make sure that you're flipping your sign correctly as you're typing those into Desmos. Now, our last step for each of these is going to be to go ahead and graph it. So we are going to go ahead and do our number line. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, negative 5. And I see that I have my x first. So I'm going to go ahead and make a dot at negative 3. However, this is going to be an open dot because it is a greater than or less than. I only have a closed dot if it is a greater than equal to or negative or less than equal to. So whenever I do not have the equal underneath, I'm going to go ahead and have an open circle at that point. And that's because negative 3 is not my answer. So I'm kind of avoiding the negative 3. Greater than is to the right. Also, in your letters first, you can see which side looks like that inequality. And then we finish up by connecting those together. So that is the graph of my inequality. Let's go ahead and take a look at a second example. So we have negative 6 times the quantity 1 plus 7x plus 7 times the quantity 1 plus 6x is less than or equal to negative 2. So we're going to go ahead and do our double distribution. Here we go. So I have negative 6 minus 42x. 7 times 1 is positive 7, plus 42x is less than or equal to negative 2. We're going to combine our like terms. I have a negative 6 plus 7, which is 1, and my negative 42 plus 42 cancels out. So I have 1 is less than or equal to negative 2. Now, it's odd because my inequalities has disappeared. So when my variable has disappeared, I ask myself the question, is this true? Now, if your answer is yes, this is a true statement, then your answer is all real numbers. If your answer is no, this makes a false statement, then your answer is no solution. So we're going to go ahead and take a look and ask ourselves, is 1 less than or equal to negative 2? And of course, that is not true. That is false. 1 is greater than negative 2. So my answer in this case is no solution. And when we graph a no solution, we are going to simply leave an empty number line. We still need to have our number line. We just don't put anything on it because there's nothing there that would go ahead and make that statement true. So let's go ahead and have one more example here. -2 times the quantity 2 minus 2x minus 4 times the quantity x plus 5 is less than or equal to -24. So once again, we're going to distribute. And we have -4 plus 4x minus 4x minus 20 is less than or equal to -24. We're going to combine like terms. -4 minus 20 is -24. Our 4x minus 4x cancels out, and we have less than or equal to -24. So once again, our variables have gone away, and so we have to ask ourselves, is this a true statement? So is -24 less than or equal to -24? And of course, our answer is yes, that is equal to each other. So we have to be careful because if it was less than, it would be a false statement. But because that equal sign is there, then we know that our answer is going to be all real numbers. And then we're going to go ahead and graph this. As we graph our all real numbers statement, we're going to do our traditional number line. 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. And we are going to actually highlight the entire graph and have arrows for both sides because we know that any number continuing forever in both directions is going to make this statement true. Okay, so ladies and gentlemen, we're going to go ahead and practice this and practice with graphing. Make sure you're using a ruler and solving inequalities.